turning off live captions. Whoops. I accidentally clicked turn on live captions. I want to click start recording. Apologies. Yeah. So since I didn't hit the start recording button, to those of you who are watching this live, welcome. To those of you who are watching this in recording, hello to the future. And to those of you who aren't watching at all, doesn't matter, you're not going to be addressed. Back to the problem. Make chocolate. I just read the question. I have done no logic yet, so you're all caught up. Hello, Coolio. Back to the live lecture. Apologies, I'm a fool. So what I'm going to do first is I'm going to check the goal, and I'm going to find out how many big bars can I subtract. So the first thing I'm going to do is I need to find out how many big bars possibly could I want to subtract. So how do I want to do this? This question is really hard because the first thing you always want to do is like, well, if I do big times 5, that's how many units of chocolate my big bars have. And then if I did goal divided by big times 5, what this will do is it will tell me what my goal is after I remove the, or I guess goal mod big times 5. What is my goal after I remove all of the big chocolate bars? But I need to make sure that I don't remove too many. That's why this question is a little bit iffy. So let's break it down situation by situation. First, let's code to the test cases. So let's assume that big will never be greater than goal. So in that case, what I could do is I could do goal equals goal minus big times 5. Not big times 85, big times 5. What this will do is it will take my big chocolate bars, however many I have, multiply it by 5, and subtract that from goal. I'm going to just use that as a place for now and come back to it later. Because this lets me then determine if goal is bigger than small, if my remaining chocolate bars that I have to deal with is bigger than what I currently have, return -1. It's impossible. I do not have enough small chocolate bars to make this. Else, return small minus, or goal minus small. Whoops. Or actually, yeah, return small. I don't have to worry about goal. Now this works for a bulk majority of the situations, except situations like this. For some reason, it's returned small. What it should do is return the difference between small and the remaining goal. So this is 2. I shouldn't return small. I should return goal. That accounts for that. Now, here's the situation I was actually worried about. 6 to 7. If I do 2 times 5, that's 10. 10 is greater than the goal, though, which means that I need to reduce how many big chocolate bars I'm using. I need to find out how many big chocolate bars are actually going to count towards my goal. This is a pretty hard part. So if goal if big times 5 is greater than my goal for any reason, then I need to account for this. In the else case, I could just say goal minus big times 5. What I then need to do is find out how many chocolate bars actually go into this. If I have 2 big bars, that's 10. That's greater than what or that's greater than 7, which is my goal. So what I'm going to do is use modular arithmetic. That sounds like a good idea. So I want goal to be the remainder after being divided by 5 big times. So goal mod big times 5. If you guys don't remember, the mod guy is simply remainder. So what this says is take big, multiply it by 5, and then find out how much is left over. Now, if I had 2 times 5 is 10, 7 mod 10, that's not going to work. So I need to find some other way around this. Does anyone have any suggestions? I'm trying to break this down into as many problems as possible, but this is a pretty hard question. So I want to see if anyone can get ahead of me. Because the end solution does require a bunch of, well, when I say a bunch, it does require small steps, but I want to see if anyone has any ideas. I don't think anyone has any goal or any. Okay, so if my goal is smaller, I am right with assuming it's mod, but big isn't a factor anymore, right? In fact, only 5 is a factor. Now you might be going, well, why is only 5 a factor? Well, at the end of the day, if I have more big chocolate bars than the goal, that means that let's say I have 10 kilograms, but only 5 kilograms of those can actually go used. The nearest multiple of 5 is what's going to end up being used. I don't know what multiple of 5 that is, because big could be any number. It could be 2, 3, 7, 1 million. But I know that if I go one higher, the multiple of 5 is too high. So I'm just going to look for the closest multiple of 5. In this case, however, big times 5 doesn't outshine it. It is not the biggest multiple of 5. My goal could be 15, and I have one big chocolate bar. That leaves my goal at 10. It's not the nearest modular of 5, though. That's the issue. Does that make sense, or do I have to go back? I want to make sure that I'm not going and leaving people behind. All right, I'm not seeing any complaints and no one spoke up yet, so I'm going to cross my fingers and I'm going to move on. Worst case scenario, this is only 4 lines. You guys could probably trace out what each of these does. So I'm going to move forward. So string 2, XYZ there. String 2, XYZ there is a fun question from what I remember. Return true if the string contains XYZ, where XYZ is not directly preceded by a period. So I need to check if XYZ in string. So first I could immediately go if XYZ not in whatever string, return false. This is the easiest case because if there is no XYZ, there can never be a situation where XYZ is followed by or is preceded by a period. So cool. There's no XYZ. I don't need to worry about it. From here on out, I can assume there's an XYZ because if there wasn't, it would have been caught right here. So what I need to do then is I need to find all indices, like all occurrences of XYZ. And what I need to do is I need to check if it was a period prior to that index. So I'm going to use a good old fashioned for loop. For I in range, starting at the beginning, going to the length of the string. However, I'm going to do very similar to something we looked at last week. I'm going to look at the string in chunks. And specifically, I'm going to look at them in 3-letter chunks, meaning that I need to -3 plus 1 because I'm going to be going from I to I plus 3. If string at I to I plus 3 is equal to XYZ. Then what I'm going to do is use an AND clause to check if I minus 1 is a period. So if the string is XYZ and the item immediately before that string is not a period, then I can return true. Else I return false. If I run that, all of the test cases are correct. Now, this hopefully isn't too hard to understand. Like, this is a lot easier than make chocolate. Find an occurrence of XYZ, check if there's a period before it, which voids the situation. All right. Moving onwards to sum 13. Ooh, I don't remember this question literally at all. So let's find out. Return the sum of numbers in an array, returning 0 if it's an empty array. The number 13 is very unlucky though. So it and any number that comes immediately after does not count. This I think is why I made a mistake on the do you guys remember in tutorial 2 there was a question that looked at sum A, B, and C. However, if one number is 13, all numbers after don't count. This is the same situation except only the item immediately to its right does not count. So sum equals 0. General idea. For I in... Actually, you know what? I'm not going to use a while loop. Because I'm going to need to change whether I'm going up by 1 or 2, I'm going to use a while loop. While loops give me more control on how I change the index. So I think that it's going to be the easier of the two. Less than len nums. So what do I do? So I'm going to work off of this test case here. Or yeah, I need to check if a number. So if nums at index I is equivalent to 13. If it is equivalent to 13, I do I plus equals 2, and I move on. I don't care. The reason I do plus equals 2 is because if this was 13, then this number 2 should also be ignored. If it was 13,221, these two numbers don't count, these two do. So in the else statement, I will do else plus equals nums at I plus equals 1. And I should just be able to return the sum. List index out of range. Why is the list index out of range? Yes, I forgot the first sentence. Return 0 if it's an empty array. I can do that. If nums equals list index out of range. What has triggered this? Because if it's empty, it shouldn't have an item 0. Else, I starts at 0. I can do this as well, the shortcut. Then while I is less than the length of numbers, so if the length was 4, I only want 0, 1, 2, and 3. The moment I is higher, then it shouldn't count. If nums at I equals 13, I plus equals 2. Continue. This was a moment of me not having something that was very important. The loop can't run this code if it's 13. So I either need to continue the loop preventing it from ever reaching this point, or, and you guys are probably more comfortable with seeing it like this, I need an else statement. This is also going to work. And that's because no code can run after this I plus equals 2 part. So you need to stop the loop at some point. Hence why you need an else, or if you are like me and you don't like else, you are welcome to do continue and take these guys out of the if statement. So this continue just says, cool, the loop is done. Yes, there's more code. No, that code does not matter. Skip it, move on. And with that, that's the end of the coding that problems. These two were a lot easier. This one sucks. This one, logically speaking, is pretty demanding, and you have to break it into a lot of steps. All right. So I'm gonna kill those. Go to this guy. And yeah. We're gonna cover the last two sections. Tutorial 4.py. I'm just gonna work in a Python file instead of your typical Jupyter notebook, mainly because it's faster, and at the end of the day, it's still pretty similar. So I have two questions to cover: the greatest common divisor or greatest common denominator, and Roman numerals. Nick wants these covered because they're questions that are in the practice test. If you guys don't know, there is a practice test. I can hold on. I would like to just say I hate Microsoft Teams because they have blocked my tabs with a stupid pop-up message that says give control, which is not appreciated at all. Anyways, so if you guys go to the course webpage, in one of the topics, there's a practice test, topic 4, structured data types. This practice test contains quite a few questions. Increasing numbers in a list. I really recommend doing this one, guys. You'll see it again soon. Not in the test, but on an assignment. So, standard deviation, reversing a string with a loop, translation, Roman-ish numerals. The reason we say ish is because of this test case. I believe this is, yeah, Roman numerals, the proper version. String slicing, greatest common divisor. This is the first question I'm going to do. And then a fun product scanner. All of these questions are pretty helpful. However, we're only going to be covering a few of them. So the first one I'm going to cover is greatest common divisor. It is the easier of the two questions we're going to be looking at. Given a number n and m, return the greatest number that evenly divides both of them, assuming they're positive and greater than 0. Def GCD takes in an m and an n, returns something. I don't know what it returns though. Well, I do, but I'm making this up. And what's a good test case? 12 and 16. So I'm going to show you guys two ways to do this, one using recursion, one using a loop. The loop makes more sense. Recursion happens to be faster because recursion is something called Euclidean's method. So the loop, or actually it's not recursion. It's still a loop. It's just a recursive looking loop. It's hard to explain. Anyways, let's look at the loop version first. Pretty easy. The greatest common denominator looks at every I in a range starting from the maximum of either n or m, and it goes to 0 but backwards. So from 0 to n to the maximum digit, whether it be 12 or 16 or whatever, and we go backwards, and all we do is if I mod, oops, if n mod I equals 0, so if n is divisible by I and m is divisible by I, we return I, else we return, I say we return 1. However, if you guys notice, this guy, he very much deals with that situation for us because I, in this range, will always eventually be 1. So you don't need to return 1 because that case is covered here. Now, I have my loop wrong. Why do I have my loop wrong? Well, I'm pretty sure range, I'm going to ignore this phone call. I don't know why they have called me. They're really calling me. Apologies. I'm not picking up yet. I'm gonna assume range does it backwards. I don't like if this is the correct answer, but I think this is what's happening. Yep, that's what's happening. So if you look right here, there's a 4. I'm gonna just run the script again on a clean terminal so that way you guys can see. It prints the number 4. If I made this 16 is not divisible by 3, so they share nothing in common. It returns 1. That's the greatest number that divides both of them. And you can even see if I remove that return, it will still return 1. This loop starts at the biggest number and works its way down towards 1, and every number is divisible by 1. In this case, when both are 16, the answer is 16. This is a pretty easy method, but it's not the fun method. There's a method called the Euclidean method. Many math students will know this. So first we need to have consistency. If n is, I'm trying to remember how the Euclidean method works. Euclidean method is actually, why bother explaining it when we can Google it? GCD Euclidean method. I swear, if I Google this and it doesn't come up. Euclidean algorithm. This is an entire Wikipedia article that explains it for me. That's not what I care about, though. What I care about is code and implementations. Here's the pseudocode for it. So I'm going to take the pseudocode, since pseudocode and Python code are very similar. Not exactly, but I hate everything. And I'm going to translate this into Python. So function isn't a word, def is a word. GCD, take some variables, I don't care what they're called. Immediately there's a while loop, so I'm going to code a while loop. And it says while b is not 0, in this case, m is my secondary number. So while m is not 0, t, which I'm assuming is some sort of temp, gets set to be b. So temp equals b. Whoops. Then b equals a mod b. Now remember, there is no b. I forgot that myself. And there is no a. I need to replace these with, of course, what I'm using them for. And then a gets set to temp. And finally, what we would do is return a. And I forgot again, I'm not using a or b, I'm using n and m. So that's how you translate something from pseudocode to Python. However, I can then realize all I'm doing is swapping the variables. M equals n mod m, n equals m. So what I'm going to just do is use Python's notation and make that one line. And if I run this, I run this and I get 16. Did I swap the variables wrong? N equals M. If I run this, does it work as intended? Yeah, I think I just swapped the variables wrong. Well, you guys can try and figure out how I swapped the variables wrong. Or I didn't. Oh, well. Yeah. If I do 16 or 12, still exact same answer. This is technically recursion, but it's not. It's hard to explain what this is actually called, but you guys will never have to worry about it as long as you give us something that works on a test. Like this is equally as valid as for I in range max mn 0 -1 if I mod if n mod I equals 0 and m mod I equals 0, return I. This is just as valid if you prefer it. We never force you guys to pick an answer. Anyways, really easy question. Let's look at one that's not easy. Roman numerals. Roman numerals is a really hard question. What I'm going to do is I'm going to show you one-way conversion. And I believe the conversion it asks in the practice test is integer to Roman numeral. Yes, the practice tests ask you for integer to Roman numeral. Your challenge afterwards is to go from Roman numeral back to integer. It's very similar, but not exactly the same. So we're going to have a function called int to Roman, and it takes in some integer n. I'm also going to need some sort of dictionary. And the reason I need that is every number has an associated key, an associated value. The number 1000 is the letter M in a Roman numeral. The number 900 is the letters CM. It is a different case. 800 is, testing my knowledge, D. Is 800. There is no 800. It's 500. That's D. 800 is not a special case. 500 is a special case. Some of you guys are going to be like, that's not how Roman numerals work. No, trust me, I've got this. 400 is CD, I think. CD or DC? I never remember. 100, well, that's our good old C. 90 XC. If I remember all of these, I'm gonna treat myself with a cookie. That's for sure. 50 L, and then 40 would be extra large. Sorry, if you're a Starbucks fan, grande, since they don't have extra large. Everybody knows 10 is X. Everybody knows 9 is IX. Everybody knows 5 is V. Oops. Everybody knows 5 is V. Everybody knows 4 is IV. And finally, 1 is I. And of course, 0 is an empty string. So, but that's not important. And then I need a variable. This variable will be called Roman. This is where I'm going to build the string, the Roman numeral string. Now, again, I'm a fan of while loops when they're called for loops when they're not. And in this case, I need both. I need to know while n is positive, and I need to do for everything in the range of num divided by, and then we stop. Because this is where it gets a bit harder. What I want to do is I want to take the number, divide it by 1000. I'm going to then take whatever the result is and append that many 1000. So if the number is 3000, I know that my string will be I don't know what happens after that, but it will be and I'm going to append the letter m that many times, and I'm going to subtract I'm going to subtract 1000 from that number. And the reason I'm going to do a for loop for this is because there's a fun situation where if I take my dictionary keys, I'm going to take my num and I'm going to divide it by, oh no, I can't do that. What I need to do is have an I variable. This will make sense in a moment. So I have my dictionary keys. I know 1900, 500, 400, but I need to go over them linearly. So I need to specifically get the 0th key, 1000, then the first key, 900, then the second key, 500, then the third key, 400, then the fifth key, 100. And what I'm going to do is I'm going to divide the number by that key. So 3,228 integer divided by 1,000 returns 3. It was 3,000 divided by 1,000 is 3. And I'm going to do this instruction 3 times. The instruction will be Roman plus equals whatever my dictionary key is, or whatever my dictionary value at that key is, I should say. So values at I. There's a better way to do this. I'm not going to do it that better way. I mainly want you guys to experience with that better way. And that should be n. You guys were probably, what is num? It should be n. So I'm going to say my string of Roman literals will be whatever the value is at the dictionary, M, C, M, C, D, CD, C, XC, L, XL, etc., etc. And then n minus equals whatever the key's value was. One thing I can do, actually, just to clean this up a bit, is key equals that, put key here and key here. And since I have the key, I could do dictionary at key. That's just to clean it up a bit, so that way it's not so ridiculously long. This will then continue. However, what do I need to do with I? Because I'm looking at the keys one by one, 1000 to 900, I need I to go up by 1 every time. Start at 1000, go to 900, go to 500, go to 400, go to 1000, go to 90, go to 50, go to 40, go to 10, go to 9, go to 5, go to 4, go to 1. And then finally, after all that work, I can return the Roman. This is a tedious question. It is actually pretty hard. Whoops. Int to Roman. Well, I need a number. Someone give me a number. Give me a number that you guys really like. Just so we can test that this works. 9. I don't know if that was the most boring solution we could have gotten, but 9. Dictionary keys is not subscriptable. This. I need to list the dictionary keys. Because yes, you can't get an index of something that isn't a list. 9 should be IX. If I look at 9, there's IX. Okay, someone give me another number. Something big. Something higher than 1,000, please. Oh, 31 will be the last two digits. I need 4543 31. Let's see how long this is, shall we? Oh, I love how many there are. So there's that many and then CCC XXXI. If I do 4331, something a lot more reasonable, there should only be 4 MMMM CCC XXXI. 31, if you guys are curious, that's the XXXI. 3 10s and a 1. This is a long question. It is a pretty hard question. Like, this part does require the correct mindset going in. You need to know how you want to do it by hand before you can do it by code. Look at 1,000. How many times do I divide by 1,000? Add the letter M that many times. Go to the next one. Fun fact, you don't need the loop. Let's say I don't want to do this with a loop. Remember that I have my key, and I know that I want to add the key the amount of times that n is divisible by that, or I want to add the letter m however many times this is divisible. So if I think about it, I could just take this number, multiply the string, and boom, that's the same thing. And then for n, it would be key this many times. Because n divided by key returns how many times we repeat the instruction, I could just use multiplication and actually remove the entirety of the need for that nested loop. If I run this, I should still get the exact same thing. If I went back to our 43 example, it should still be the exact same thing. How you choose to approach something can be done many different ways based on how you understand it. When I first think of Roman numerals, I don't think of this method. When I want to repeat an instruction 3 times, well, a loop is dedicated for repeating an instruction 3 times. But that's not always the way you have to go about it. And with that, tutorial's over. We have finished the problems. But we still have 8 minutes. As is typical, question time. Hit me with your best shot. And if you have no questions, run away. Oh, I got one person leaving. Will these type of questions be on the midterm? 100%. Guaranteed. No hesitation. Zero hesitation. The midterm and the final exam are hard questions where you are expected to do it by hand 2 or 3 times, learn the instructions, then code those instructions. All right, got another person leaving. Seriously, this is the time to try and dig for information. Like, if you have questions about the exams or the midterms or stuff like that, Shoot now. If there's a topic you need reviewed, shoot now. Because I've got 6 minutes. How many questions will roughly be on the midterm? We have a history. We never go higher than 8. Our targets for tests are usually 4 or 5 with 1 bonus. That being said, you could expect 8 questions with 1 bonus at the absolute maximum. We don't know what the target is yet. Like I said, I feel more comfortable saying 5 with 1 bonus than 8 with 1 bonus, but like you could genuinely see 8 questions, 1 bonus question, 24 hours just like an assignment, or you have 24 hours, it's distributed just like an assignment and marked just like an assignment. The bonus question also is not enough to justify skipping another question. Like if you are struggling with a question, doing the bonus question does not absolve you of the marks you would have lost, but it will prevent you from getting a very bad grade. We also do not recommend skipping the bonus question. A lot of people, like they skip the bonus question, not even paying any mind to it, and when they lose marks, they're like, "Can you boost my mark? Can you boost my mark?" And we always have to look them in the eye and say, "No, you were expected to do that. If you wanted to boost your mark, do the bonus." The bonus on a test also covers any mistakes on an exam. Really important question, or really important point there. So if you get 115% on this test, that's 50, or that 15% extra could float over to the exam. It won't actually be percentage, it will be the actual mark. So let's say you got 126 out of 120. In that case, those additional 6 marks are put on the exam regardless of the denominator. So that could be 6 out of 40, or that could be 6 out of 170. These are just made up numbers for examples, but the bonus question will save your ass. Whether it is now or later is yet to be seen. Yes, it is very nice. It is a luxury that this course has a lot of luxuries. I'm not going to lie. But like we don't pull punches on the final exam. That's one thing I always caution to people. The final exam is always meant to be a proper test. Hell, for the last 3 semesters, our final exam averages has been high 60s to low 70s. Any more questions? Oh god, that is scary. Yeah, it is scary. Now that's an average though. Remember, that's an average. That is not necessarily saying that if you go on or if you're going into the test and you do badly, you're guaranteed, or you won't ever do good or something like that. That's an average. Doing well on the midterm is very important. Yeah, the midterm is only 20%, but the midterm is an accurate reflection of how well you're going to do in this course moving forward. Because the midterm is placed right at the this course is no longer holding your hand point. If you do genuinely bad on the midterm, it is cause for concern. If you do genuinely good on the midterm, that is cause for celebration because the likelihood is you'll do pretty good on the exam. These again are not 100% statements, like you could 100% a test and then 0% an exam, but it is a good indication if you do well on the test that you will do well on the exam. All right, I'm killing the recording. So everything